Hey guys, welcome to my new tutorial. This is Docker beginner step by step. Let's get started. I guess you are using Docker because it's very famous and you want to know, how you get some benefits out of that. So in this video, I'm going to explain to you what are the benefits of Docker, how to get started, and what exactly it's all about. So let's move on. Let's move to my blog first of all, because I have written already an article. It's a blog post about this, and if you open that, there's a link just below the video. If you open that, then you can follow along and copy all the comments and everything from that post, into your tutorial materials. So what is the you might ask, why I want to use Docker? What is the problem that is solving for me? And the problem that Docker is solving is that if you want to create a web application, for example, let's say WordPress, or you want to use a database like MongoDB or MySQL, what we usually do is that we install the related software on our local machine, then we do something, then we install the related software on a test machine or a production machine. We deploy our code and hope that it's all gonna work and hope that everything is gonna have the same version and everything. Now, Docker works differently. Docker gives us dedicated environments and separate environments and identical environments, most importantly, across all the stages of development. So if I create a Docker container to run a WordPress application, then I can use the same Docker container configuration in my production. So that will give us the more security and more confidence that those environments are identical, and I won't have so many issues or no issues at all because the environments are different. So this is the Docker solution to this long problem of identical environments in computing science. And let's go to the terminology. So what is Docker about? Docker has containers that you probably know. So containers are running instances of running operation environment of different applications basically. And let me show you how that works. So if you look at my own computer, this is my local Mac. So if I say Docker PS lists, by the way, all the containers that are running on your machine. So if I say Docker PS, you can see that I'm running a MariaDB container on my machine right now. And if I say Docker PS-A, then it will list also the containers that are not running, they are stopped. So you can see that I have an Nginx proxy, and I have 2 WordPress instances and a MariaDB. And I usually run node instances as well and all that crap, but right now this is everything that I have. So MariaDB is a running container, and this is my local development database. So if I go to this guy here, this is a MySQL client, and I open up the MySQL client, go to my local host, say connect, and look at the database, then you will see that I have WordPress tables in here, and I have WordPress data in here, and everything you see here is coming from this local database. So before I use Docker, I used to install MySQL with Brew. As you can see, I also have it installed right now. I used to install MongoDB, Node, NVM, and all these guys, everything with Brew. And right now, if I go MySQL server status, then you can see that MySQL is not running. I'm not running MySQL locally anymore because I'm running MySQL in a Docker container. So simple. So this is basically Docker. You can just get hold of any application you want to use. You download the image and start up a container. So image is a new term. I haven't used it so far. So image basically the definition of the environment. And if you start up an image, that is called a container. Container is a running instance of an image. So you download the definition once, you download the image once, and then you can start multiple containers, multiple instances of the same image. That's just like I have done with WordPress, for example. So I have the WordPress image, and I started 2 WordPress images with some different configurations. So they have 2 containers based on the same image. I hope you can understand this, and I hope this makes sense. So if I go Docker images on my machine, then you can see that I have a couple of other images here locally. Don't worry about the first 2. These are custom images. I made them, I created them, and I will tell you how to do that. But let's just say I have a node image, which is basically this node. I have an Nginx proxy, which is my Nginx. This is a local proxy. It's not running anymore right now, but this is what I usually use. WordPress, I have a WordPress image. As you have seen, I have started 2 containers from that, and I have another node. As you see, the version is different, so this one is the latest node, and this one is an exact version of node. And I can tell you that you better always use the exact version of the environment, but I will tell you later why and how that works. And I have MariaDB. So these are the containers that I'm running right now, or these up here, these are the containers, and these are the images that are present locally, and I can use these immediately to start up new containers. And yeah, that's the meaning of Docker. If you want to start a project in some new technology, you just grab an image, you start up a container, and your environment is ready. And then if you want to move that same package, same application to staging or production or testing or to another development machine, then you very simply grab the same image, start up the image with the same configuration, and there you go, you have the same environment. That's the essence of Docker. That's it. And so let's first of all, I guess the most important thing is that you have to install Docker on your own machine, right? So let's go to my website here, and running Docker on your machine. In this part we have a link, and let's open that link in a new tab here. Okay, here, and there is only a few things I want to tell you about the installation of Docker. Installation of Docker on Mac and Windows has changed. So this environment is changing quickly, and when you see some tutorials online, they are outdated. So when you see a tutorial that is telling you to use Docker Toolbox here or boot to Docker, then please make sure to understand if you need to use that, or you can use the native version of Docker. So right now, the way to install Docker is to install the native application on Mac and on Windows. And the native application is not boot to Docker, and it's not the Docker Toolbox. So there are certain requirements. If you fall under these categories, then you can install the native application and you are good to go. But if if your Mac was, for example, produced before 2010, then you need to do the harder way, the other way. Okay, so let's get started. Click this link and please install Docker on your machine, and I will be waiting. So please stop the video. I have some water right now. Okay, and once the installation is done, let's move on. So the Mac installation is a step-by-step guide. The Windows installation is the same thing, is step-by-step stuff. And on Linux, please go to your specific distribution and see how to do that. So after you installed, you should be having an icon in the top bar that says Docker is running. So when we say Docker is running, that means the Docker engine is running. This is part of the terminology. So what you need to install and run on your machine is the Docker engine. So what does the Docker engine do? The Docker engine has the ability to run containers. Okay, so simple. So Docker engine in the background technically runs a Linux virtual machine, and Docker containers are based on the Linux container technology and Linux container methodology. And all you need to know about this right now, and I will show you some details about this later, that Docker containers are really efficient because they share resources. So when I'm running a couple of containers on my machine, that means that those containers are sharing the same kernel in the background, but from the application point of view, they look like separate and isolated virtual machines. So they have their own file system, they have their own users, that they have their own environments, and they have their own resources. And so applications think that they are running in an isolated environment, because this is what's happening. But in the background, the containers share a lot of resources. So this makes them very efficient, and at the same time, they save us a lot of time, headache, and effort, because they just solve some very essential problems of environment management. Okay, so now that we have installed Docker, then the Docker engine is running, then we should be having the command line tools as well. So let's go to terminal and say Docker dash dash version, and this is the version of Docker, and let's say Docker compose, which is another important component of Docker. And you see that you should be getting a response to this, like some meaningful version number if you run these things. This is, by the way, not the latest right now. I will upgrade to the latest very soon, but it doesn't matter at this stage. Okay, so now that we have installed Docker, the question comes. We are running containers and we are running web applications in containers that are started from images. So this is what we discussed so far. So where do images come from? How do I get an image? And you get the images on Docker Hub. That's the answer. So let's go to hub.docker.com, which is this website here. Let's click explore. And I did it. I clicked that. And this is the repository of Docker images online. So here we have the technologies, and there are a lot of technologies. So if you want to try and develop stuff, you know, you want to play with Mongo, just do it. You want to play with MySQL, you want to play with Postgres, you want to play with Node, HTTPD, WordPress, you name it. You look at this stuff. If you say that this is the official image, that means that that's really the official image of that technology. That means that, you know, there are images provided officially and there are images provided by the community, so third party. And I can show that to you so that you can better understand. So Nginx, for example, is the official image here. Then if I search for Nginx, then you see that I have a lot of other images by third parties, by people, by the community that are also somehow related with Nginx. They have some different configuration. They are specialized for something, okay? And how can you understand which is the best image to use? It's a very good question. You can, of course, play with them and try them, but there are too many. Then you can Google them and see what others use. And you know, if you want to just get started, the official image is usually your best bet. So another hint here is to look at the number of stars, which is the rating on the Docker Hub, or you can look at the number of downloads. This is the popularity of an image. Okay, so you go to the Docker Hub, you see all this beautiful technology, you decide which one to use, you grab an image, and then you start up containers, and those containers will run the applications for you. Okay, this is the meaning of Docker. So let's check out. We're gonna use Nginx in this tutorial, and let's see what's behind this Nginx page, because this is a very important resource and a very useful resource. I'm clicking this. Okay, so this is the page, and I found that these pages are very resourceful. So they are full of valuable information, and believe it or not, this is a kind of documentation that can you get started. So thank you, well done, very well done. You can expect that most of the images on the Docker Hub have a good documentation, and if you look here, this is a short description, official build. Okay, that's fine. You say Docker pull, which means if you want to get this image, just do Docker pull, and then you can grab that. It will download that image locally into your local image repository. Okay. Full description. This is the useful part. So there is some version information. We're gonna talk about that in a minute. There's a description. You know, what is Nginx? Nginx, by the way, is a web server and a reverse proxy. So we're gonna use it as a web server today. And then how to use that image. This part is pretty cool. So it tells you exactly how to serve HTML pages from this web server. It tells you how to map the port. I will show this to you and explain why. It gives you some configuration options, environment variables, and so on. And then we have some issue description, documentation description, and there are some community comments and so on as well. So this is pretty cool. This is very informative. Let's go to the version numbering. So if you look at my Docker images locally, you see that I have, for example, from the node, this is another image. This is a node image, and I have 6.6.0. And while I also have node the latest. And you know, this is tricky because the essential idea of Docker, what we want to achieve is to have the same environment everywhere and run our code in the same operating environment. So if you want to do that, you better use specific versions, because if you use a label like latest, then the version number behind the latest label may change. So today maybe the latest is 6.6.0, but maybe tomorrow the latest will be 6.6.2. And if you're just using the latest, then you will end up with different versions in different environments, which is not good. It will cost you money and pain. Okay, so here you will find all the information related to the versioning. You have the latest this is the latest version number. You have a stable number as well, so there are latest versions and stable versions. And if you go to tags, then there is usually an even more detailed information about all the versions that are ever available. And yeah, some of them are not available even, but they are still listed. And and so right now, what we want to say, we need to make a choice whether to pick the latest or pick the stable. But let's pick the stable. And we need to make a decision whether we want to pick Alpine or not Alpine. So what the hell does that mean? So that means that, as I said, Docker is based on the Linux container technology. And that means that every Docker container or Docker image is derived from some kind of a Linux distribution. And this one here, the not Alpine, so the other one, I would say, let's say the default, is based on Debian Jessie. So Debian Jessie is a Linux distribution. It's a Debian, I'm sure you heard about that. It's one of the big names. It's a very feature-rich, very stable, very strong distribution of Linux. So this version, the latest and the stable, these two are based on Jessie. It's also in the name. Alpine, on the other hand, is a trendy distribution, and many Docker images started to move in the direction of Alpine because it's leaner, it has a smaller footprint, and it's optimized for stability or specialized for stability. So, sorry, for security. So the thing is that we can pick one or the other. You can see the size of the Jessie package. I can show that to you. The size of the Jessie package is 71 megabytes, and the size of the Alpine package is 17. So this is one of the differences. But I believe this is not good enough, you know, to make a good decision or make a good choice. Please make your research, understand which is best for your own case. If you do some complex stuff or production stuff or for money. But for the tutorial right now, I would just say that let's use Alpine. And let's go for the stable version of Alpine. Okay, so excuse me. Oh, let's have some water. So what we're gonna do? We're gonna grab this package from the Docker Hub. Okay, so we say Docker pull nginx. Let's go to terminal and say Docker pull nginx, and then the version number. It's 1.10.2 dash Alpine. And if you run this, then it will pull the image. So all it does, it's like any other package manager or like GitHub, it will just pull that image and save those files locally. So it will be done in a second, hopefully not more. I have some more water then. Okay, so we have downloaded. So if I say Docker images, images here, then you say that there's a new image on my list, which is nginx, and this version here. Okay, so what do I need to do to start this locally? Okay, the first thing that I gotta do is that I gotta say Docker and run. Docker run is the command that will run an image and start a container out of it. Okay, so you can also follow along and copy and paste the commands from my blog, so that you will do that easily. So you can find the command also here. So what we're gonna do, the first thing we gotta do, that we're gonna give it a name. Why this is important? Because this is a human readable name that you give to your containers. You can always know what's going on. So for example, if you do A/B testing, then you can say that this is WordPress A and the other one is WordPress B, for example. So let's call this my nginx, And then there is one very important point that I will explain to you. So we are starting a web server, an Nginx web server, and in order to start that, we need to understand something. And that something is, when we start a container, there will be an Nginx server running inside that container. It's a web server. It's going to expose two ports, port 80 and port 444, sorry, 443. And and those ports are exposed by the container, and that means that those ports are not available as the ports of your own machine. They are not exposed on the host machine. They are only exposed on the container. So if you run multiple containers that expose port 80, you need to understand how to map those to the ports of the host machine so that you can use all your containers. So right now what I got, because by default I won't be able to access that port 80 in my container. I can only access that if I map it to a port on my host machine. So the first port that I have to give here is the host on the port machine. And I give it the port 80, which means that this is going to be my default local host HTTP server. And yeah, to just show you what I'm doing, I'm not serving anything. I have no servers up and running. So I just map it, the port 80 of the container, I map that to the port 80 of the host. And then I say, okay, Nginx, and then 1.10.2 dash Alpine. Okay, so I start this up and it's up and running right now. So nothing has happened, but because I'm running this right now in the foreground. So if I click this, I have the welcome page of Nginx here, and you see I have one request already listed under this command. So if I do another request, I have another line, and if I do another request, I have another line, which means that this is right now my local host server. Okay, so let's celebrate first of all. Let's smile and say, okay, you know, this is how complex it is, or how easy it is actually to grab an Nginx HTTP server locally. So you don't need to install, you don't need to configure that much. You just pull that image and run that. And by the way, you can do that in one line. So if you say docker run, so if you launch that line here from the terminal, and if the Nginx image is not downloaded, not yet pulled locally, docker run will pull it for you. So with this one single line, you can pull that image and start a container. So this is how easy it is to replicate one environment to another, to a new machine or to a new computer. Okay, let me stop this and tell you something about this. So this is pretty important. Then if I say docker ps right now, that you see that I only have MariaDB running and nothing else, because this image is not running anymore. And I will stop MariaDB as well. Okay, just to have a clear picture. Okay, and if I list all the images, then you see that my Nginx image that we just started, or the Nginx container that we started, is is still here, so I can restart it. Okay, that's pretty cool. But let's say what happens if I want to start it with different parameters. So you have seen that our Nginx server, the container is running in the foreground. What if I want to run that in the background? All I need to do is add another runtime parameter which says -d, which means that it should run as a daemon. But the thing is with Nginx or with Docker containers that you cannot change the runtime parameters of an existing container. So that means that, for example, if you want to change the port mapping on an existing container, you cannot do it. If you want to change, if you want to add another runtime parameter to an existing container, you cannot do it. Even if you stopped it, you cannot do it because you created that container and it has those parameters. So what you need to do, you have to launch and create a new container. And it has some practical disadvantages. First of all, that you know that if I start another container with the same name, I'm gonna have a conflict. And you may think that, okay, let's not be so stupid, let's give it another name. but after a while there will be too many names. So what I usually do is that I remove the container before I start it again, because then these things will be just, you know, they stick around and they never go away. So let's go docker rm, which will remove the container nginx, and I have removed that. So if I go docker ps-a, you see that that thing has gone. Okay, so let's go back to the starting script here, and let's say that I will add like -d here. And now you see I have a long ID and I got the prompt back, which means that this thing is running in the background. You see it is running because docker ps says it's running. Port mapping is okay, and I'm still running a local host, so it's still running, but I have changed it right now. So let's stop it again, or okay, let's not stop it, let's leave it running. So okay, so the thing is that you cannot change a running container, you have to create another one instead of this. And this has a lot of implications, because if you start up, and I strongly suggest that you Google this part. So if you want to start a container with new runtime parameters, you have to create a new container. You cannot change an existing container. That means that any data or any user generated content that you have put into your container will not be available in a new and reconfigured container. And that means that has a lot of implications. So for example, if you're running a MariaDB and you want to start at MariaDB on a different port, that means that all the data in that container will just disappear. They will not be available in the new container. So what we usually do is that we do not put data into our containers. And I will show you how we do that. We will put data outside the container and map that data into the container with volumes. It's very simple. I will show you how that works, okay? So let's do the following. I want to create a configuration file and map that configuration file into our nginx container. So let's do that, okay? So first of all, this thing is running, and I will show you something very handy now, okay? So that's docker exec. Docker exec is a command that can execute a command inside a running container. So -ti is that we're gonna run this in an interactive mode, okay? And this is the name of the container. So I'm gonna run on the my nginx runtime this thing here, and we're gonna run in interactive mode, and I will say /bin/sh, which is shell. I'm gonna start a shell. So right now I'm inside that container, and I see this is the root file system. And yeah, who am I? I am root. This is so amazing. So turns out that the container that we are running it looks like a standalone Linux machine. And I am root, and I can actually apply changes and run stuff inside a running container. Those things that are running inside the container will have an effect until this container is running. So when you stop the container, your changes will disappear. But then for that runtime, the changes will be still there. So what I want to do is to give this container a config file from the outside. So I happen to know, I don't happen to know. I have checked this. I show you where to find this. So let's go back to Docker Hub, and on Docker Hub we have the nginx description, and under complex configuration here, look at this line. So it is docker run. This is the name, and this part here says then if you want to add a config file from the outside into this container, then you have to map a volume, mount the volume. This is the local directory, so whatever you have, and map that local directory and that config file in that local directory into the config file that is at this path in the container. So if you do this, you will override the config file in the container with the config file on the local machine. This is what volume mounting -v means. So let's check what's there. So let's check cat etc nginx nginx conf. So this is the file that is here. So you look at this, I'm not cheating. And this is the content of that file. So let's copy that. Okay, and let's leave the container. Let's say docker ps. I'm gonna stop this because we're gonna change this, and I'm also gonna remove this. So right now that is gone, and let's open up a text editor, so Sublime Text or whichever editor you like. I've been using Sublime Text in the last couple of months. Again, return to my old friend. And I already have a config file here, so please create a config file in a local directory and copy and paste the contents of of that file that we just copied from inside the container, what we copied. Let's copy and paste that into here, okay? And let's save this. So once we have saved this, we're gonna map that. Let's change the configuration. So let's say, how shall we go about this? So what I want to do is that right now this line is commented out. So whatever we have, it's not compressed. The responses coming from the HTTP server are not compressed. So let's uncomment this line, and from now on, we're gonna get compressed responses. I just wanted to show you that previously in the original setup we did not compress, but let's leave it. Please believe me, or you can take it as a homework and try it for yourself. So previously we were not compressing, and now we have uncommented this line. So if we apply this config file to the container, we're gonna get zip compression. So this is what's gonna happen. So let's close this. Let's come back here, and our config file is here. So just let's take the path of that. So this is the path, and let's go back here, because this is what I like. I go back in history, and then I say, okay, let's mount a volume and use this thing here, copy and paste, and let's not forget to put the config file, because we are mapping the entire file. And then we are do etc nginx conf. This is the path inside the container. This is the path that we looked up in the documentation, because some really nice people put the right thing into the documentation. RO means read only. Many people use this restriction, which means that we are mounting this file in a read only mode, so the container and the runtime will not change it. That is what it means. Okay, so we have the read only, and everything else stays the same. So if we go here and refresh this, you will see that this is not running. So now we start this stuff, okay, and you see it is running now. So if we go into the developer tools in Chrome, we go to network, and let's refresh this page. We click on localhost, and then you see that the encoding, this is zipped. So right now we are serving a compressed content. And if you want to know what I use here, this is a clear cache plugin in Chrome. I usually use this for development because it helps me clear the cache and then refresh the page. So if you cannot see the compression, don't worry, because if you do this clean cache stuff, then it appears suddenly. So it doesn't always work. It's not really reliable, but if you clear the cache, then it becomes reliable. So what we did, we mapped a config file into our server. So let's do something else. Let's see how we can do development with this stuff. So locally, if you do local development, you have to make sure that your local files and your code get into the container somehow. And now I guess you probably understand that what we got to do is to create a mapping and map that stuff, map the code into our container. So let's stop this again, because we're gonna start it in a new configuration. Okay, so I have removed it, and okay, let's say if you list this, I've already created a source directory. Maybe I will show you in Sublime Text. So I have a source directory, I have an index.html file under that. So please create something like this on your computer, create a new directory, and hello world from Mark, this is the content in a paragraph. This is the HTML page, HTML line that we're gonna serve. Okay, so this is our source code. So what we're gonna do is that we go to that directory. So this is the source directory, and we take the path of that, and we create another mount point. So we mount, this time we are mounting the directory. So we are not mounting individual files, we are mounting the entire directory. And what is the folder in the container itself? Again, we can go back to Docker Hub and look up that thing. So hosting some simple static content here. You see, this is the part here. This is the directory in the container. So if we use this, we're gonna map our source code into that container. So if I start this again, it has restarted. And now if I refresh this, hello world from Mark, it's already there, you see? So I have very simply just mapped my source files into the container. And the good thing is, I mean, what is the essence of development? Let's change this stuff. Okay, so I'm changing this, and I'm refreshing this, and ta-da! I'm changing the code, and the stuff changes. Pretty cool, right? Okay, this is a simple scenario. If you want to have hot reloading and all this stuff, I don't have a tutorial about this yet, but I'm not gonna talk about this now. Maybe later, or maybe Google it. But essentially, this is the way that we put stuff into Docker. Okay, so this is pretty neat. So what else am I going to tell you? Okay, so let's quickly go back to my post and see if I have explained everything. So these are containers. This we have done this. We have executed the shell in the running container. We mounted the config file. We also mounted the source code, and yeah, there's one thing left, and I will do that too. So the one thing left is, let's create our own Docker image. So you have seen that I have some custom images running. So I'll show you how I've done those. So Docker stop, let's stop this thing again, my nginx, and let's remove that thing as well, nginx, okay. And here in this folder, I have a Docker file. So it is a file that's called Docker file. So the way you create your own images is that you create a file that is called Docker file. So, but first of all, why on earth would you want to create your own image, right? That's the question. So the answer to this is that you may want to have a dedicated configuration, your own version of an image with special config. In a Docker file, you have an opportunity to install new packages like apt or any other package manager under Linux, so you can create your own environment. And the good thing about Docker file is this is a basic tutorial, so maybe we'll talk about this in the next one. But essentially what you need to understand, and please Google it, that you need to understand that the Docker file and the Docker image is a layered structure. So every line on this file is executed one by one, and it creates a new layer, and it commits a new layer into the image. And it is important because if one part of that image step-by-step configuration changes, then Docker will only rebuild those layers that have changed. So the layer that has changed and all the layers up from that, starting from there, will be rebuilt. But the layers that are before the change, those remain untouched. So this saves a lot of stuff. For example, if you're using Node and you have a package.json, then if your package.json changes, then your whole thing will be rebuilt. But if your package.json doesn't change, then your image will not be rebuilt, or at least the npm installs will not run again, but some other stuff may run. So this saves you a lot of time and effort and so on. So, but let's not go into detail. I'm using it in my projects, and it works pretty well. So the best thing, all that we want to do right now, just create an image, okay? So we got to start with the from. From is always another image we start from. So right now we are starting from this Pine nginx image, the same version, and you always need to specify something to start from, okay? Maintainer, it's you. It's yeah, the best thing is that you can put your name on it, your email address. If you want to have a lot of bug reports, even put your phone number. That would be a strange idea. And okay, so what we're gonna do, we're gonna essentially copy that nginx config file from the local directory into the image itself. So what that means, that we are not mapping that volume, so it's not a logical reference, we are not mounting this thing, we are copying the file exactly into the container. It's going to be part of the image. So whenever we start up that image, that configuration will be already included into the image. Okay, so let's see how to do that. So what we gotta do, we gotta build that image. So docker build is the command. Docker build is the command to build the images. And -t, t means that we give it a tag. And tag means that is a name plus a version. So let's call this zip nginx, which is, you know, this is a zip version of nginx because we changed that config file to zip the stuff. And let's say this is 1.0, and what we gotta do here, we put a dot. Dot means that please use the local directory, the current directory, to build the stuff. So what Docker will do, it will look into the current directory, see if there is a Docker file in there, and once the Docker file is found, then it will build the image. So let's see how that works. It's a breeze. It happens in a matter of a second or less than a second. The image is already there, so we can go Docker images, and then you see that we have a new image that says zip nginx 1.0. Okay, so what we're gonna do now, so if I go Docker ps, that's just to double check if I close, yeah, I have stopped everything. That also means that if I refresh this, nothing will happen. Pretty cool. So so what we're gonna do, we're gonna start up a new container from our new image. So yeah, let's list this up again so that we know what's going on. And okay, so this is the command that we use, and most of it will be the same. The name will be different because we will call this container myzip nginx, and -d, that works well. And we need to remove the configuration mapping because the config file is part of the image. Just remember that. And we will be still mapping the source because that's the same thing. And the port mapping should be in place, that remains in place. And we are not using this image to start the container. We are using another image that is called zip nginx 1.0. Okay, so let's see what happens. So we have started this stuff, and let's refresh this. Hello world, it's coming from our own beautiful custom image. Okay, if you go localhost and look at this thing, let's refresh this. Unreliable beast, and it says okay. I know this issue. This is pretty neat. So it doesn't say that it's compressed, but I know what I gotta do. Let's change the source code. Let's refresh everything. So hello world from Mark, and now it suddenly appears. This is what I said. It's not really, it doesn't work the same way all the time, but don't worry, we have compression built in by default, and we have the source files mapped. So this is the end of the tutorial. And okay, there's a couple of things before I do the summary. So there's one more thing on the website, on the post here in my article, and that is Docker Compose. And I think Docker Compose has a place in the beginners tutorial, but I don't talk about this too much. Docker Compose is a tool that lets you create multiple containers from one file. So you create a composition, you can add runtime configuration like port mapping, all the stuff that we have done now in the command line. You can do that in a file, and you can do that in a way that you are basically connecting two different containers in one file, and then you say Docker Compose up, and then you get everything that is in the file up and running. I've used that. It's important you understand that you have this possibility to combine containers and start them from one file in one big move, And I think for a beginner, this is enough to know that you have this possibility. And if you want to use it, please go online. Docker has pretty good documentation on this part, and there are of course other tutorials, and maybe I will do another tutorial on that. So let's keep that for later. So what we have learned today, we have learned how we can install Docker on our own machine. We learned the terminology of Docker engine, Docker containers, Docker images. We learned that Docker containers are running instances of Docker images. We learned that the source, the resource place of Docker images is basically Docker Hub. So if you want to get Docker images, then you go to the Docker Hub. Well, we also learned that those images are typically very popular and common web applications like databases, web servers, Linux distributions, all these things. So you can essentially grab those images, grab those web applications, grab those web components, grab those runtimes, and start them locally. And they save you the headache of configuring the hell out of your local machine, or configuring the hell out of your servers in the cloud or wherever. You just install the Docker engine and the start up the containers, and then you get the same environment everywhere. So it gives you a lot of benefits, and I hope you will really use it, and I hope you will have great success with Docker. And yeah, see you in the next tutorial. Cheers.